Hey all, let's tackle some Bayes Theorem and probabilities. So with Bayes Theorem, we're given a set of prior probabilities and then we get some new or supplemental information that allows us to update our probabilities. We get a new posterior probability. So let's start with an example. So let's say that Naomi owns a business and it organizes and promotes music festivals. She's currently working on developing the social media content for an upcoming festival, and she estimates that about 20% of her Instagram followers are university students, and she'd like to create posts directed toward these students specifically, some student-focused content. She doesn't know exactly which of her followers are students, but she thinks that if she has some extra information, it will help her identify students better. So she calls up the university and they can't give her a list of their followers or whatever, but they do tell her that 80% of students at our university follow the university's Instagram page. And comparatively, only about 7.5% of the local community follows the university's Instagram page. And if this breakdown is the same for our followers, we're in business. This will help us answer the following question. If one of our followers is also a follower of the university's Instagram page, what's the probability that they're a student? So instead of blanket spamming all of our followers with student-designed content, we can just focus on those that are our followers who also follow the university's webpage. So, Bayes' theorem, the hardest part is getting ourselves set up. And when I do that, I do two pieces. I create a little table where I can enter my values, and I also write down the equation, and I try to figure out which pieces of the information I have plug into the equation that I've got. So I start with the question that I'm trying to answer, because in this question will be the probability, the posterior probability that we're trying to solve for. And we want to know what is the probability that one of our followers is a student if we know that they also follow the university's Instagram account. Right, this is our question. And if we try to write that in the language of Bayes' theorem, we want to know what the probability is that they're a student if we know that they also follow the Instagram account. So there's something we're searching for, right? The probability is a student. We don't know if a given follower is a student or not, but we do know that they follow the Instagram account. So our unknown is A, and the known is B, right? So what we're looking for, we are looking for the probability that someone is a student given that they follow the university's Instagram account. Probability student given they follow the university's Insta. Let's get a little bit more specific, right? In here, we then can see that A is that the person is a student, and we don't necessarily need an A prime, but A prime is basically that the person is not a student, because someone either will or will not be a student. You're one or the other. Those two things are complements. And B in this case is going to be following the university's Instagram account. All right. So now we can identify the probabilities given in this question, and we can kind of map it out given the equation. So we're given the probability of A, the probability that somebody is a student, and that is 20%. 20% of our followers are students. And then we're given two additional pieces of information. 80% of students follow the university's Instagram page. So the probability of following the Instagram page, given that they're a student, right? That's what we're looking for, is 80%. We can also think of this as saying the probability of following I'm just going to call it following uni's Insta if you're a student. All right, that's the probability of B equals A. So now we have this entire numerator because we're given the probability of being a student and the probability of following Instagram given that you're a student. However, in the denominator, we need the probability of B. We need the probability that any one of our followers follows the university's Instagram account. And we don't know what that is. We know that the probability of B for non-students, right, the community majors, the probability of following the university's Instagram for community members is 0.075. So we're pretty close already to being able to solve this equation. We're just missing B. So let's take this equation, bring it down here, and let's solve what we have. We don't know probability of A given B. That's what we're looking for. But we do have the probability that someone follows the Instagram account of the university given that they're a student, and that's 0.80. And we also do know that the probability of any one of our followers being a student is 0.20. But we're not yet sure of our followers what the probability is of any one of them following the university on Instagram. But we do know that the probability of B is going to be equal to these two joint probabilities. The probability that it's a student, that our follower is a student following Instagram, the university's Instagram, or the probability that our follower is a community member following Instagram. And so I'm just going to put this as a placeholder here for a second. And I think that might be helpful. So let's pop up here and fill in the parts in our table. So A goes in this first column, in column A, whether someone is a student or not a student. So somebody is either, one of our followers is either a student or they are not a student. And with regard to our followers, 20% of them are students. And then since someone is either a student or not a student, and this applies only to this first column, we can just do 1 minus the probability of being a student, right? That's 80% because these are complements. The conditional probabilities that we have are the probability that a student's going to follow the university Instagram account. Well, in this case, we know that 80% of students follow the university's Instagram account, but only 7.5% of community members do. These two do not have to sum to 0. Do not have to sum to 1. And so our joint probability is equal to our prior probability multiplied by that new conditional probability, that updated information. And we can see that down here. These are the joint probabilities. The joint probability of somebody being a student and following the university's Instagram, plus the probability of someone being a community member and following the university's Instagram. That is these two pieces here. And if we add them together, we end up with the probability of following the university's Instagram. And so we can basically see that from our followers, there's about a 22% chance that our followers also follow the university's Instagram account. So now we can update this equation and we can replace this denominator with the number 0.220. So now that we have the new information on the student versus non-student breakdown of university Instagram account followers, we can calculate the probability that a given individual who follows the university account and also follows us is a student. Because basically 16% of our viewership is both a student and a university follower, out of the 22% of our viewership that is also just a university follower. So if we know that one of our followers also follows the university, we estimate that there's a 72% chance that that person is a student. And with that information, we can make a conclusion. If one of our followers also follows the university's Instagram account, there is a 72.7% chance that the individual is a student. So if we're looking to develop social media content specifically designed for students, we should share it with our followers that also follow the university's Instagram page. I hope having another example helps. Okay, happy calculating.